This is a recap for Monday, March 15th. And it's kind of a makeup for last Thursdays that didn't get posted. So what we're going to do is go back to CAMI week 21 and fill in all the answers that maybe we didn't go over last week. So this is for week 21, the CAMI for week 21, where we were talking about similar figures. So this was page 1. So pause here if you need this information. And I'm going to scroll down. And here are our definitions. So I'll zoom out a little bit so you can see that a little bit better. So there is the symbol for similar, the symbol for triangle, the symbol for a line segment, for an angle. And remember that the vertex has to be the third. If you're going to use 3 letters, it has to be the second letter. The vertex, or the sharp, pointy part of the angle. And if I'm just reading right here, this is angle A is congruent to angle B. That means they're both similar and equal in equal in measurement. And then I circled the ones that are true statements. So true statements are circled. So that's circled. So let's kind of check off the ones that got circled. That got circled. That A is congruent to G. BCDA is similar to HEFG. Line segment AB. The ratio line segment AB and GH is proportional with line segment CD in a ratio with EF, but not the bottom one. And this is part that we didn't do in class, so I will fill in these answers in case you're working on this. Let me zoom in just a little bit. CA corresponds to line segment SU, and angle C is congruent to angle S. And AR corresponds to line segment UN, and angle A is congruent to angle U. And CR corresponds to line segment SN. It should be line segment CR corresponds to line segment SN, and angle R corresponds to angle N. Line segment DO corresponds to line segment CA. Angle D is congruent to angle C. Line segment OG corresponds to the line segment AT. Angle O corresponds to angle A. Line segment DG corresponds to the line segment CT. And angle G corresponds to angle T. And the question is, are the line segments congruent or similar? So congruent means that they're similar and the same size. So these have the same angles. So 60, I just check those 60, 60, 30, 30, 90, 90. So I know that they're similar. This is 3 feet, 3 feet, 5.5, 5.5, 6. So they're all corresponding. Not only are they proportional, but it's 1 to 1. So if I was to make a ratio, it's 1 to 1. It's the same size. So they are congruent. These angles, all the sides are proportional. And we can check that because 4 to 6, I got that 4 and that 6, corresponds to this 4 and the 6, but more importantly to the 2 to 3. It's 12. If I do cross products, 12 equals 12. So sides are proportional. corresponding sides are proportional. Okay, determine the scale factor of the similar figures. So I am going to go left to right. So whichever is on the left goes first, and then the right, instead of small to large. So that is 4 to 3. That is the scale factor. It's 4 to 3. So this one is 8 to 16. 8 to 16 simplifies 1 to 2. And I'm going to write it like this because scale factors are usually like this. 1 to 2. This one is 4 to 3. This one is 15 to 24. And 3 goes into both of these. 3 goes in there 5 times. 3 goes in there 8 times. So that's a scale factor of 5 to 8. This one is 15 to 9. 3 goes in here 5 times. 3 goes in here 3 times. So that's scale factor of 5 to 3. And this is 4 to 12. And that simplifies 1 to 3. This one is 12 to 21. And let's see, that simplifies 4 to 7. So the scale factor is 4 to 7. Find the value of find the value of x on each pair of similar figures. So 3 over 6 equals 4 over x. 3x equals 24. 6 times 4 is 24. Divide by 3. X equals 8. 8 feet. This one we have to be careful because it's been rotated, and that corresponds right there. So the x is going to correspond with the 14. So I'm going to use the small first. So we'll call that small, we'll call this large. So this is going to be x over 14. Those correspond equals 18 over 12. Now what's interesting is this 18 seems shorter than this 12. So this is no longer small to large. This is large and this is small. But notice how it doesn't change anything over here. I'm still consistent. It's this one on top, right here, and this one on the bottom. So it doesn't really matter if we call them small or large. It should work either way. So 12x equals 14 times 18. Grab a calculator here. Let's see. Okay, 14 times 18 equals 252. So 12x equals 252. Divide by 12, and we get 21. X equals 21. So 21 feet. And this seems like it's not rotated, that it's lined up. So we can do this. 15 over 20 equals x over 12. So 20x equals 15 times 12. 20x equals 180 divided by 20. X equals 9. That's in inches, 9 inches. Okay, page 5. Here is the answer to the height of the tree. And find the similar triangles have a scale factor of 3 to 5. So I could literally just do 3 and 5 like that, and if I wanted to set it up that way. So I could do, I just took that, this is small and this is large. So 3 over 5, those correspond, equals a over 8. So 5a equals 3 times 8. 5a equals 24. Divide by 5, 24. Divided by 5. A is equal to, let's see, it goes in there, 4 and 4/5, or 4.8. And to double check that, here's what we can do. 4.8 divided by 3, 4.8 divided by 3 equals 1.6. 8 divided by 5 equals 1.6. Another thing we can do is we could do 3 divided by 5 and we get 0.6. And then we could do 4.8 divided by 8. 4.8 divided by 8, and we also get 0.6. So we have consistency. Haken is standing next to a building whose shadow is 15 feet long. If Haken is 6 feet tall and casts a shadow of 2.5 feet, how tall is the building? So the shadow is small, 2.5, and actually, let's do it this way. We're going to do small, large, example 1, example 2 equals. Okay, so the height is big, or the person is small. So the person is small, and so we're going to do, he is 6 feet tall, and his shadow is also small. And I'm going to draw a quick sketch of this because I may not be setting this up the way I want. So here's the person, and here's his shadow. And so I want 2.5 right there. Okay, and then the large thing is the building. So that's 15 feet. But we don't know what that is, so we'll put X. And the building shadow is 15 feet. So example 1 is the height, and example 2 are the shadows. We could have done it a little different way, but this will also work. Okay, so 2.5 times X equals 6 times 15. 2.5x equals 90. Divided by 2.5, 90 divided by 2.5 equals 36. X equals 36. The building is 36 feet tall. Find the value of D. So we're going to do 1.5 over D, those correspond, equals 4.05 over 7.29. Okay, we've got a bunch of decimals here, but the same thing applies. 4.05 times D is equal to 1.5 times 7.29. 4.05 D equals 1.5 times 7.29 equals 10.5. 10.935. And I'm going to guess that this is going to come out evenly. We'll see. We'll do 10.935 divided by 4.05 equals 2.7. Not bad. So D is equal to 2.7. I always like to see if that makes sense. And it seems to be 4 to 1.5 seems like 7 and a little bit more to 2.7. Okay, that works. Right, 3 more problems. Find the x in the polygons below. So I'm going to do small and large, x to 4. So I got that x and that 4, they match up. And 0.66 to 1.5. So 1.5x equals 4 times 0.66. 4 times 0.66 equals 2.64. 1.5x equals 2.64. We're going to divide that by 1.5. Divided by 1.5. Make sure we've got yards, yards, and yards, so we're okay there. Divided by 1.5. X is equal to 1.76 yards. And that seems about right. 3 times that is a little bit more than that. 3 times, yeah. So we just want to make sure that there's a multiplier that kind of makes sense. Okay, so 1.76. What must the value of x be in order for the figures to be similar? So let's do x over 16 equals 22 over 32. So 32x equals 16 times 22. 16 times 22, 352. So 32x equals 352. Divide by 32. Hopefully it's something fairly even. It is, 11. So x equals 11. So 11 centimeters. So x must be 11 centimeters. And that makes sense when we think about that this side is half of this side. 11 is half of 22, 16 is half of 32, so that works proportionally. We already have an answer for the height of the tree, which it looks like it was 44 feet. There's an answer right there. And the last one, the tallest tree in the United States is coastal redwood in Jedediah Smith State Park, 321 feet tall. Suppose you have a 5 foot 8 inch tall. So you are 5 feet 8 inches, and you cast a shadow that's 2 feet. So I'm going to change feet to inches in this case. So 5 times 12 is 60. So we're going to say 68 inches tall. And you cast a shadow that is 2 feet. So I've got a 2 foot shadow. How long is the tree shadow? So since I used inches here, I'm going to have to use inches. So 321 times 12 is 300. So we'll write this down here. 321 times 12 is 3852. So 3,852. And we want to know, well, how tall is that? How long is that shadow? So 68x equals 2 times 3,852. 2 times 3,852. 68x equals 7,704. We're going to divide by 68. Divide by 68. And it's around 113. So I'm going to try it one more time just to double check. 7,704 divided by 68. So x is around 113 inches. So we divide that by 12 and we get about 9.4 feet. So definitely something went wrong here. Because, how do I know? Because this right here is about 2 or 3 times as tall as this shadow. 9 feet, that would mean the tree would be around 27 or 30 feet tall. So we're going to look for our error here. We're going to look for our mistake. So this is small and this is large. This is small and this is large. And we're going to see if we can find this error. So this is 3,852. I think I know where the problem is. 3,852. That's the number of inches. That seems right. I'll double check it. 321 times 12. 3,852 inches. That's right. These are inches. And we multiplied it by 2 times 2. 7,704. Oh, I know what has happened here. Okay. And so let's see, right here we got, this is the problem right here. We've got the answer 113, but it's not in inches. We don't divide it by 12 because this answer right here is feet. We multiplied it by that 2, so that's feet. So, and that makes sense, 113 feet. So around 113 feet. So we'll put it right here. It's right around 113 feet. Now here's what we're going to do. We're going to erase this and we're going to do this in a second way. So if you want to see this, you're going to have to pause right here for what I did because I'm going to erase it and I don't need to change it to inches. We can do it in another way, which we're going to do to double check our 113. Just because we made that error right there. Our error in our thinking, we're going to double check it. Okay, so I'm just going to get a little bit more space here. And this time we're just going to use a decimal. Okay, so 8 divided by 12 is 0.6 repeating. So, or we could do it this way. We could just say that instead of 5 feet, we could say 5 and 8/12 or 2/3 of a foot. Or, right. So this is, a person is 5 2/3 feet tall. And the tree is 321 feet tall. The person's shadow is 2 feet. And let's do x. So we're going to do 5 2/3. So we'll just keep it all in feet. 5 2/3 x equals 2 times 321. 5 2/3 x equals 2 times 321. 2 times 321, 642. So we're going to divide that by 5 2/3. Divided by 5 2/3. So let's change 5 2/3 to, let's see, 17/3. So 642 divided by 15/3. That's the same as 642 times 3/15. We could simplify this to 1/5. So 642 divided by 5, that's going to be 113. $642 divided by 5 is 128. I wonder if it's 128 or if it's 113 feet. So in this way, I've got 128.4 feet. So we're going to think about this just a little bit more to make sure that all of our reasoning is correct. 3 times 5 is 15 plus 2 is 17. Ah, there it is right there. I found that error. So this is 17 right here. So that's going to fix it for us. All right. So let's fix this. And this is going to be a 7. That should fix it. 7. So we can't simplify that to 1/5. We have to do instead 3 times 642. 3 times 642. That's 1,926 divided by 17, and that's going to be 113. Divided by 17, and look at that, 113.29. So we'll round it to 113 feet. So either way we did it, we got around 113 feet. So 1926 divided by 17 gave us the same answer. So whether we were keeping it in feet or changing it to inches, we got the height or the length of the shadow to be a little over 113 feet. And I also said that I would put the answer key to Pear Deck, page 2, in today's wrap-up. So let me go to Pear Deck real quick. And boy, if you're listening to this part of the wrap-up, congratulations, you have a lot of patience. Good job. And let's just go here. And I'm going to go to card 2. And I'm going to zoom in a bit. Not quite that far. And let's write this in with this. And I'll write in red. Okay, so this is the point 5-2 for the pineapple. Oops, there we go. Wow, okay, let's erase all this. Wow, my eraser, come on eraser. Nope. Okay, click on the eraser. There we go. Okay. Pineapple. Wow, I don't know why it is doing that. I know, because I'm zoomed in. All right, all sorts of issues today. So we can't zoom in. Zoom back out and just see if I can read it. Okay, so the pineapple is 5.2. The onion is at 8.1. The apple is at 2.2. The, let's see, eggplant is at 1.10. And is that broccoli? I think it is. It's at 9.5. 9 first. 9.5. And the tomato is at 2.2. And what do we have at 9.7? Looks like a lemon maybe. And 2.7 looks like watermelon. Sorry about the bad writing. 3 over 3 up 4. Is that a parsnip? I think maybe it is parsnip. Or an onion. It's this one right here. And then 7.3 looks like maybe another tomato, but I'm not sure what that is. It's like because that looks like a tomato, but we're gonna call it another tomato. But as long as you know where to go, that this is 7.3 right there, and that's really all I need. And boy, that is a wrap up of Monday, March 15th.